Alright, let's look at the practice exam 3, problem number 10, part A. Alright, so let's test this series. Alright, so whenever you look at the series, and first test you should try is a divergence test. So let's try that. And this is going to be our AN. So this is AN. Oops. So we want to see if the limit of the sequence AN actually goes to 0. Right? Alright, let's check that. To make our lives a little bit easier, if you look at the limit of as n approaches infinity, alright, I'm going to just ignore the negative 1 to the n for now. So you have a 2n over 3n plus 1. Right? So this one, we can use the trick. We can multiply top by 1 over n, bottom by 1 over n. And then you will get this limit. So you have a limit as n approaches infinity. So you have 2n over n is 2, 3n over n is 3, and 1 over n is 1 over n. So you have that. Right, then we have 1 over n going to 0. So we have the limit is actually 2/3. Right? Alright, so which is not equal to 0. Right? And which this means that here, if you take the limit of this AN as n approaches infinity, AN is this guy right here. Right? So we know that this portion, without the negative 1 to the n, this guy approaches 2/3, right? Then what this guy does is the alternate sign. So it's going to go positive 2/3, I should say almost a positive 2/3, then the negative 2/3, positive 2/3, and negative 2/3. So this sequence is going to kind of go between, positive 2/3 and a negative 2/3. So never approaches a particular number. So therefore, this limit actually does not exist. Right, which means that of course it's not going to be equal to 0 because it doesn't even exist. Right, therefore, this series is going to diverge by divergence test. So this is by, oops, sorry. All right, I have to get rid of that. And here, by divergence test. All right, that's it. I hope that this was clear.